All right, AP Stat, in this video we're going to look at some more examples. So I'm sorry that I'm jumping around so much. I really didn't know what order I wanted to put these in when I made your notes, so hopefully you're surviving. Okay, so in example 11, that's what we're going to talk about. Just take a few moments to pause this and read the example. We want to know, or we are explaining how confounding makes it unreasonable that to conclude that a mother's smoking during pregnancy causes an increase in the risk of ADHD in her child based on this study. So keep in mind that this is not an experiment. You can't force people to smoke while they're pregnant. It's not ethical. So what we're looking at here is a study. So when we're asked to explain how confounding makes it unreasonable, it's just like the ice cream sales and deaths by drowning. They do have a positive correlation. As one goes up, the other one goes up. But it's silly to assume that if ice cream sales go up, we're automatically in graver danger of dying by drowning. So what is happening here, there's something confounding acting upon both of those things to make them increase. So just because as there's an increase in mothers smoking and there may be an increase in her child developing ADHD, that's not necessarily going to be the reason, because it may be possible that mothers who smoke during pregnancy might also have other unhealthy eating habits. So there could be something, or maybe they don't work out or they don't take care of themselves the way they should. So it's likely that there are other things that are possibly contributing to her child having ADHD. It's not necessarily the smoking. Okay, so the next example we are going to look at is example 14. And example 14 is all about designing experiments. So take a moment, pause the video, read the example. So when I'm describing a completely randomized design, well, anytime I want to describe a completely randomized design, unless I'm specifically asked to show how I'm randomizing, I don't necessarily have to show the randomization itself. I just need to describe a completely randomized design. Well, a completely randomized design is going to take these 100 freshmen and 400 sophomores, and it's going to dump everybody into the same hat together. So I've got 500 students, and I am going to randomly, so my randomization right here, randomize. This group is going to be treatment 1. And that's going to be the online geometry course. And I'm going to put 250 of them in that course. And then treatment 2 is going to be teacher lecture geometry. And I'm going to put 250 kids in that. And then I am going to compare final exam scores. Now, for this particular experiment, yes, you really can write it this simply. Like, they'll take this on the AP test. You can write it out in paragraph form if you want to, but you can also write it just like this. And I got a good question in class about this. Would this be a situation where there are just 2 treatments and 1 factor and 2 levels? And this is definitely a situation where we can address that. Obviously, there are 2 treatments, right? And the factors, the factor is the learning style, or the teaching style, I should say. Teaching format, let's go with that. That sounds good. So the factor would be the teaching format, and there are 2 levels. So since there's only 1 factor with 2 levels, there's a total of 2 treatments. So that's how that would work. Okay, so on part B, we're asked to describe a randomized block design for this experiment. Justify your choice of blocks. Okay, so for this is a randomized block design. Now, you can write it out in paragraph form, just like I've done here, or you can use the same type of system I used up here. If I use this, let me get rid of some of this, and I'm going to need a smaller pen. All right, so if I were to show you a randomized block design, I would take my 100 freshmen, that would be one block, and my 400 sophomores would be another block. Okay, so I believe that freshmen and sophomores may respond differently to the two types of learning. So I am going to randomly, so you randomize across here, place them in treatment 1, which would be the online, and I'm going to put half of them here. And in treatment 2, teacher lecture, I'm going to put 50 of them here, and I'm going to compare freshman final exams. Final exam scores. All right, I will do the exact same thing for sophomores. Once you block, okay, it is important that you realize when you block, you never bring the blocks back together. You think they're going to behave differently, so you don't bring them back together. It's kind of like doing 2 experiments in one. So teacher lecture, I'm going to put half of my sophomores in here, and then I'm going to compare sophomore final. Sorry, my handwriting's getting bad. I'm getting tired of doing this. Okay, so I never bring them back together, all right? The freshmen stay in a block, the sophomores stay in a block. That's what a randomized block design would look like. All right, and notice right here, justifying your choice of blocks, you form blocks based, dang it, you form blocks based on grade level because the scores are likely to vary by grade level. So blocking can always be done if you've got a justification for it. I'm not just going to block because I feel like it or because there are 2 groups. For instance, if I give you information and I say, okay, we have 35 freshmen boys and 15 freshman girls, and we have 60 freshmen or 60 sophomore boys and 40 sophomore girls. Create an experiment for this, blah, 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 blah. Just because they're separated by gender and grade level doesn't mean you have to block. You only block when you believe that you're likely to see some variability based on a certain characteristic. All right, so for this should be part C. Explain why a randomized block design may be preferable to a completely randomized design for this experiment. Well, I've just been talking about that. So if you will look at this, your randomized block design will account for variability in the scores on the geometry final exam that may be created by different grade levels. So that is why we would want to perhaps block. Maybe that would be preferable to a completely randomized experiment.